first lesson, we talked about types. A type is a set of values and the operations on them. Types that we're familiar with are like int. The values for int are the integers, and the operations on them, well, I can add two integers, I can subtract two integers, I can multiply two integers times each other, and so on. Now that we have classes, you can make your own types. But this means that we have to have a much broader, inclusive notion of what a type is. Let's think about some unusual types. I could have a time type. My values? Well, my values are just times of the day. What types of operations might I want to do here? Well, what can I do with a time? I can ask, is one time before another? Or taking two time values, I can ask, how much time has elapsed between them? Okay, let's go think about another. I could have a type for a worker. I have values. The values are the collections of workers in a company. What types of operations do I want to do? Well, what can I do with a worker? I can hire a worker. I can pay a worker. I can promote a worker. Let's talk about graphics or geometry. I can make a rectangle type. So my values are rectangles that I'm drawing on the screen here. And things I might want to do is I might want to move the rectangle about the screen. I might want to take two rectangles and compute the intersection between them. Or I might want to ask, is one rectangle located inside of another? Look, you can make any type that you want because now we've taught you how to make classes. The challenge is, how do you go from sort of this brainstorming idea of a type that you want to an actual class definition? Okay, so that's what we're talking about when we talk about interface design. The idea is that you first start off with, okay, I have a notion of a type. That means you have to have a notion of values. So you need to think about how you're going to take those values and turn that into a class definition. Well, the first thing that you do is you need to think about what are your attributes, right? Because your object is just a collection of attributes, and objects are those values. So whatever the attributes are going to define the values for your type. And then you need to think about, well, what operations do you want to have? Well, every single operation is going to correspond to a method. So what you're really doing is talking about what methods you want to have. Oh, and by the way, your choice of operations can affect the attributes that you might want to have. So you might need to go back to the first step. For example, suppose you decide that one of my operations is that I want to pay or promote a worker. Well, that means that I probably need to have an attribute in that class for how much salary a worker makes. Okay, so once we've done this brainstorming, now what we're going to do is we're going to create the interface to formalize this process. The first thing that we're going to do is we're going to write the class specification. The class specification is going to formalize our notion of values because we're going to list out all of the attributes, and more importantly, we're going to list the invariants for each of those attributes. After we do that, then we're going to list all of the method headers and all of their specifications, because the specifications of the methods are what are going to formalize the operations that we have on the type. And then when we're done with that, finally, we're going to write all of the code that implements that particular interface. Let's go look at some examples here. So I'm going to go into Atom Editor, and here I have this class time that we've actually talked about. When I designed this class time, I decided to have two attributes, hour and minute. And let's look about some design decisions that I actually made here. I decided in my invariant that hour needs to be an integer between 0 and 23. So this means that I'm using international time, or in the US we might call this military time, instead of using an AM/PM designation to represent my hours. That's one decision that I've made. The other decision that I've made is that the only attributes are hours and minutes. If you think about it, I could have added seconds to this class, but I chose not to. I decided that for the work that I'm doing, it is perfectly fine just to have hours and minutes and nothing else. So with that in mind, you'll notice that all of the methods here focus only on hours and minutes because that's the decision that I made. If I had any method here at all that said anything about seconds, I would need to go back to my class specification and go add that attribute. Let's go look at another example. So in this case, we're going to go look at a rectangle, which is going to represent a rectangle on the screen. And let's talk about how I'm going to represent that, because I can't actually draw something in Python. I have to represent it as a collection of attributes. I chose to do this with 4 attributes. So these are essentially left, right, top, and bottom. Left and right are the x coordinates of the left edge and the right edge, as you can see above my head right now. And bottom and top are, well, they're the y coordinates of the bottom edge and the top edge. An interesting thing that you'll notice about my invariants, I'm not only requiring that these are floats, I'm also requiring something about how these attributes fit together. Namely that left has to be less than right, and bottom has to be less than top. So that's one way that I could have designed a rectangle type. But it's not the only way. I could have chosen 4 other attributes, which I'm going to draw above my head right now. I could have chosen to say x and y for the bottom left corner of the rectangle. And then my other 2 attributes are my width and my height. And that would have done the same thing. I could use that to represent a rectangle, or I could use these 4 attributes here to represent a rectangle as well. Which one is better? Well, it depends. It depends upon the operations that I want to do. In particular, if I want to compute whether or not 2 rectangles intersect with one another, then this choice here of left, right, top, bottom is perhaps a better choice, because that's going to make that code simpler. But if I want to compute something like, say, the area of a rectangle, well, maybe knowing something like the width and the height, that would be better. Let's go look at one more example. So in this case, I'm going to look at a hand of cards in a game of poker. And now we'll notice that, by the way, it really only has one attribute. And the attribute is going to be, well, I said a list, but notice that it is a list of card objects. So we talked about interface in a previous video. We said how in application we could have multiple classes fitting together. Well, that's an example of this, because a hand class, well, it doesn't make any sense without having a card class as well. Okay, so I can go over to the card class and wow, that looks pretty complicated. There are actually lots of attributes here. I mean, okay, I need to have an attribute for the suit of the card and the rank. Is it a 2, a 3, a king, or an ace? But look at this. I have all of these class attributes as well. And why do I need to have class attributes? Well, it's not enough to talk about a single card. I need to talk about, okay, what type of deck of cards am I playing with? Am I talking about a normal deck where I just have 13 cards for each suit? Or am I talking about playing with the tarot, which actually has many more cards? All right. All of this is defined in terms of the class specification. Now, for right now in this course, as you can see, this is getting a little scary because there's no right answer when you're writing your class specifications. You know, the only thing that matters is that you write a class specification and then you write the code that carries out that specification. So for right now in this course, you're not going to be writing these interfaces. These interfaces are going to be provided for you. And the only thing that you're going to do is exactly the same thing that you did with functions, which is fill in code that meets the specifications, both the class specification and the method specifications, the entire interface.